for joining the session on Data Lakehouse. The title is Data Lakehouse, the next big data architecture. This has a slight sort of pun sort of thing wherein it is both the next big data architecture and the next big data architecture, whichever one you want to take it. So that is the slight title there. So essentially, the idea behind a data lake house and the evolution of databases, which we are going to talk about, is that this particular evolution is more designed towards analytics and which is basically BI, ML, AI, right? So this system or suite is very good design for the modern use cases of AI and ML, and that's what we're going to discuss today. So what are we going to discuss? The contents. Basically, we'll have an introduction. We'll talk about database evolution. We'll talk about data warehouses and then data lakes. And we'll then talk about data lakehouses, which is the main topic of interest. And we will conclude with data lakes, which is a managed solution for a data lakehouse, right? There'll be a lot of terms that we'll be using in this presentation. In case you're not familiar with some of the terms, feel free to ask me in the comment section or later. So we'll take that, right? Okay. Right. So basically, I'm sure you've seen this sort of taglines or buzzwords where people are saying data is a new oil, and every bite has a story to tell. Some people say AI will take your job. There's a lot of hype words that go about when we talk about AI and data, right? So that's the sort of the buzz there. But the reality is that AI is indeed a pretty powerful technology, right? And why is that? Why the reason why AI is such a powerful technology, if you think about it in a higher level, so every successful business, let's say you're running a business, you start a business, then it becomes successful, and you have a lot of employees, then there's a lot of processes, etc. So essentially what happens is every successful business, at the core of it, is there's a lot of data that is generated. If there's no data being generated in a business, more or less, it's not a successful large-scale business, right? So every large-scale business will have a lot of data. So leveraging that data and becoming a data-driven business will add a lot of value. And eventually, the way evolution happens in this space is that everybody will have to become a data analyst if you want to be in a boardrooms, C-level, making decisions, etc. So AI will definitely affect a whole bunch of industries. We've already seen it happen, in a bunch of industries, but it's just going to accelerate from here, right? Primarily due to there are three main trends. The biggest trend is cheaper computing power, cheaper storage, and more complicated models like deep learning models and many other machine learning models that are making computer vision a reality, that are making NLP a reality. So the whole bunch of things that were previously not possible are going to be done by machines, which is going to increase productivity dramatically, right? And that's the promise of AI, right? Even though AI is very fancy and probably the biggest buzzword in tech circles right now, the challenge is that clean, plentiful data in a readily usable format, right? It is still a major challenge for the growth of AI. So a lot of use cases don't take off because there's not enough data, or there's not enough clean data, or managing data is complicated enough for the business to not give a go ahead for the shiny new AI use case, right? And that's where the problem is, right? Now, basically, when we're talking about data, there are these 4 V's of data, which is basically the volume, velocity, veracity, and variety. Okay, so compared to the 80s and 90s, there are these 4 new issues or features of data that have evolved, which is the amount of data which is exponentially grown, and the velocity is also pretty high. Velocity meaning you're consuming data in real time pretty much, and that's the sort of the the concept of velocity there, and veracity meaning the quality of data. Because there are multiple formats of data that's out there, multiple sources. So if you combine all of that, the quality of data obviously suffers, and that's where the veracity kicks in. And the last point is the variety, right? In the olden days, data was just a table, okay? So it was a structured format, so it was easy to handle to some extent, right? Whereas now we have unstructured and semi-structured. So examples being, there's a lot of JSON data that comes, log files, and then there's a lot of text data that comes, there's images, videos, audio. So we are now kind of, consuming all these different sources of data, hence the variety of data has increased, which made the whole exercise of handling and collecting and ingesting data far more complicated. And that's why we need this new age technologies and architectures, right? Okay, so we're going to go back to the history, and we're just going to talk about the first big evolution in databases, which is essentially the enterprise data warehouse, right? The EDW. So or you've heard of them, like you heard the phrase RDBMS or SQL, etc. So essentially in these RDBMS databases, what happens is there is a rigid structure. There's a nice table structure. There's denormalization, etc. that happens. And as a result of that, what happens is that you've got certain great benefits, which is strong asset guarantees, right? And then which is basically makes it ideal for transactions, including financial transactions or any other transactions. So if you think of all the software revolution that has happened, it is primarily driven by these databases, basically the RDBMSs, right? So the pros are, like we discussed, it's got very strong reliability for transactions. It has support for joins, so you can query these multiple tables and get the information you want. In a way, it's good for making reports. So basically, you can say, hey, you've done this many transactions today. This is how it is, et cetera, right? Now, the con is basically it's rigid structure. So you can't change the structure easily and make it happen as the way you wish. And that's a big problem because now, like we discussed previously, the variety of data is no longer fixed, right? That's where the issue comes up. And there are also no support for unstructured data like images or audio, etc. And because these data sources are exploding in nature, not leaving them aside is a problem, as we can witness, right? Now, the next phase of evolution of this is our data lake. This phrase, I'm not sure if you've heard of it, but essentially, I'm sure you've heard of the word Hadoop, right? And big data. So when we are saying data lake, essentially, we're talking about the big data paradigm, which is a map-reduced paradigm. And here, essentially, what you're doing is you're dumping all the data into commodity machines, right? Commodity machines, and you're essentially cutting down the cost, but you're having this, basically massive amount of data, right? So that's what Hadoop was popular for. This happened around 2010 ish, and then there's certain pros of this paradigm, which is basically you can store unstructured data and semi-structured data, and because it's a cost-effective, people have started storing a lot of different types of data, right? So hence the data explosion has really taken off. Now the problem with this solution is that typically the way you want to run things, you want to do some analysis, it's got a high latency because it's not structured properly, and also lack of reliability, as in the data, because there's not enough structure, you don't know what to rely on. There could be some corruption, there could be basically timestamp issues and whatnot. So all of that eventually has so-called created the so-called data swamp. Essentially, there used to be a data lake, useful one, but now it's become a swamp, no longer that useful. And if you want to change the let's say a new feature, you're going to have to rewrite the whole thing again. And then there's a whole problem of different tools and techniques and et cetera, and that's also created a whole bunch of complexity, right? So as you can see here, there's a whole bunch of use cases that we are targeting. We want the BI, we want support for BI, we want support for reporting, we want support for data science, we want support for machine learning. So all these different use cases have to have different tools, and all these tools and different developers, they need coordination. So it becomes a pretty challenging task, especially when you're dealing with a lot of data. Okay, so and that is the kind of like the bigger picture issues, right? So to boil down the issues with data lake are that reading and writing data lakes is not reliable, right? Because they don't have enough structure and governance around them. That becomes complicated. So the quality again is low, right? What do we mean by quality? So you assume that let's say you write some data into a database, it doesn't have to write exactly like the way you intended to, right? There could be some issues there. So all of these issues over time creep up and then essentially make the job of analyzing difficult, right? And yeah, the bigger issue at hand is modifying, updating, deleting. I'm not going to go into depth on why that is the case, but that is the biggest issue. So if you want to modify, you want to update, or you want to delete, that's where the biggest challenge is with the current data lake architecture, right? Now we're introducing data lakehouse architecture here. The picture is from a book called Data Lakehouse in Action, which is a very good book, introductory book for you to understand how the whole data lake works. But essentially, the way data lake works is that they've got separate structures for each of the components on top of the data lake, right? So you've got the data lake here in the central part of the picture, right? You have 7 different other new structures that are added that make the whole thing far more reliable and far more consumable for our use cases, right? And that's what the advantage or the architectural change of data lakehouse is about. Now we're going to discuss these features in more depth, but essentially the high level idea is that for every different type of transformation or ingestion, etc., there's a clear modularity involved. And so what happens is that if you're running airflow type jobs and you're tracking all the pipeline, you know exactly what is happening and where things are failing. That this modular approach is what I think gives the biggest advantage for data lake houses, but there are many other advantages we'll talk about soon, right? So as you can see here, this is a typical data pipeline process. You've got the data providers from where you ingest the data and send it to the data lake, and then from there you can have processing that happens wherein you can have a separate serving layer, or you can have an analytics layer, etc. And you are able to build governance on top of it and security and access control on top of it. That way it becomes far more manageable than a simple data lake, basically, wherein there's just data dumping, right? You just dump the data and then nothing happens, so it becomes a swamp very quickly. All right. What are the big features of the data lakehouse, right? The biggest features of this structure is that it supports concurrent reading and writing of data, right? And that's a very, very powerful thing compared to data lake, right? Because as we discussed in data lakes, this was just not possible because, like I said, there's a high latency to write, high latency to read. So because there's not enough structure around it, not enough governance and reliability around it, it's very difficult to do that, right? Whereas in the data lakehouse architecture paradigm, that there's a possibility for that, right? So there's concurrent reading and writing. There's a schema support, so you can mention schema, and there's a guarantee that comes for that schema. And on top of that, you can have a schema evolution. So you can change the schema later if you want to do that. That's an additional feature. The bigger advantage is that there's clear separation between storage and compute, which wasn't the case with EDWs, right? So with SQL-like databases that people use for transactions, there's no separation of storage and compute. And as a result of that, if you want to increase storage, you have to increase compute, and that is very expensive. Whereas in data lakes and data lakehouses, there's a separation of that. That creates a lot of flexibility for handling this big data type databases, right? And you can have support for semi-structured databases, whatever, like we discussed, right? Audio, video, and IoT data, streaming data, and so on, right? Not just structured data. So that's one big additional advantage. Um, the other advantage I would say is the support for streaming. So you can actually, these side of setup support streaming databases, whether it is Twitter feed, you're feeding in the Twitter feed, or IoT data, etc. So increasingly, the world is becoming more and more event-driven when it comes to data. So that means that's basically a streaming database sort of structure. That's where this architecture actually helps out, right? Uh, just 1 second, guys. For some reason, I'm not able to move my. Yeah, I'm not able to go to the next slide. Okay, I'm now able to do that. All right, okay. So what are the benefits of this? The benefits, basically, the biggest benefit is less time and effort in administration. So it's not as complicated as a data lake when it comes to administration. That's a big positive, because then you can iterate faster, right? So that's one big advantage. The schema, like we discussed, is there's a structure around it. There's a governance around it, so you're able to do that. Then there's the cost effectiveness is there compared to your EDWs. That still carries on, and this format supports both all the different data consumption, which is reporting, BI, AI, and ML. So it is a tool that fits the use case for all the end consumers of data, right? And that's a very powerful thing, because right until now, you had these different structures. So the data scientists can only work on Hadoop databases, whereas the reporting happens on a different tables, etc. So you need more people for like more structures to administer them. So there's a whole bunch of overhead that happens for in the traditional setup, right? Okay, all right. So now let's talk about the data lake, right? Sorry, Delta Lake. Okay. So what is Delta Lake? Delta Lake is basically a concept that is basically a data lakehouse concept. It's a managed version of the data lakehouse, which is developed by Databricks, right? So they have open sourced this. So and it's picking up traction pretty significantly. So, and for the reasons that we have discussed previously, right? So this has all the benefits of a data lakehouse, and it is basically tuned towards working with existing cloud databases, and the more importantly, existing object storage databases, right? So most of the cloud-based data is sitting in object storage. So data lake works with that, and that's where its main advantage comes in, because you don't have to change anything per se. And it has support for all the different use cases like we discussed previously. And you can have different analytical engines, right? So the most popular being Spark. So Data Lake has first-class support for Spark, and that's a very powerful thing, for querying, etc. Now let's go to the benefits. Let's go to the features and benefits of Delta Lake. So like we discussed before, basically it has that certain guarantees and data governance that comes, and Delta Lake has come to a point where it is able to give support for ACID transactions. So that's a very powerful thing. So which means you can dump all the data, and as long as it's in a right format in the way Delta Lake supports it, you get the ACID guarantees, right? And that's a very powerful thing. So not just that, they have the enforcement, schema enforcement, and evolution, which is also very powerful. So the reason why it's very useful is this, right? So let's say today you have a customer database, and the customer is having certain X amount of features, right? And but tomorrow you think, hey, maybe I want to add this additional feature. Maybe I want to track something more about the customer, right? And you have to add that into a database, and that's where it gets complicated. That's why having a flexible schema is useful. Obviously, the JSON type data structures do have the flexible schema, but how do you do that? So you want to go with a Hadoop sort of thing, and then you have other problems, right? And that's the kind of, so it's a balance basically, and that's where the problem is, right? And yeah, the other my favorite feature is support for Parquet files, right? In the next session, we're going to do a session on Parquet. We'll discuss in depth what are the main advantages of Parquet, but the Delta Lake supports Parquet files, and that's a very useful thing, because Parquet files have the best, so one of the best, basically speed when it comes to executing queries on these sort of files, right? And reliability. All right. Okay. So again, there's support for different types of structured data, unstructured data, etc., etc. There's support for diverse workloads, as we discussed. The other important and powerful thing is unified batch and streaming sync. Okay. This particular word, keep in mind, This is very, very powerful. Uh, Apparently, Google did a lot of research when it comes to data engineering. Obviously, Google is one of the best companies when it comes to data engineering because they've been doing this forever, right? And they have invested so much money and energy into this, right? And their conclusion is that because they're treating the batch and streaming data similarly, they're able to achieve far more reliability and far more speed and far more throughput, right? And that's what there's a nice paper on that, and Google is actually pioneering this concept, right? Which is already there in Delta Lake, which is a powerful thing for the future of data architectures, right? So it also comes with enterprise level governance and security, so that you can have fine-grained control on who to access what tables, etc. So that gives a very enterprise flavor on top of that, right? So that's a very basic high-level overview. The next session, we're going to discuss about Parquet, right? Like we said, like I told, and then we'll also discuss this technical paper on Delta Lake. It goes in detail, but kind of technical. If you're interested, you should join that session. So thanks again for joining, guys. Thanks.